Today's lesson, we're going to talk about subtraction of whole numbers and what we can do as teachers to try to teach our elementary students some different algorithms in order to learn subtraction. We have to keep in mind that our students, of course, have different learning styles, so we want to present some different ways that they could do subtraction. We're going to start off talking about the definition of subtraction. There are several ways that we could define subtraction. Subtraction can be thought of as the taking away of objects from a given set. A lot of times in elementary students, we will use a set of basketballs to be able to teach them how to subtract in different ways. Another way of looking at subtraction is to draw away from under, or it can be thought of as the process of taking away. Now, as you're going through this video and you're writing down everything that we've got written in blue, please make sure that you pause the video if you need to, slow it down, or you can go faster. Addition and subtraction, the reason that we teach them back to back is because they are inverse operations of one another. This is going to be important as the elementary student continues to grow and to get into more advanced math classes. They'll be learning that addition and subtraction being inverse operations, that we use that concept in order to solve equations later on. One useful way of teaching subtraction, of course, is to use manipulatives like the base 10 blocks. They're very useful for teaching subtraction. It's very important for students at a young age to be able to visualize things and to be able to see things. So we're going to take a moment and we're going to go to a video that I found on YouTube that talks about how we could use manipulatives to teach subtraction in our elementary class. So let's take a moment to look at that.
Let's subtract 17 from 43 using base 10 blocks and a place value chart. We have 1, 2, 3, 4 tens and 1, 2, 3 ones. Write 43 here. We want to subtract 17, so let's write 17 here. We can subtract by taking away blocks. Let's start with the ones. We can't take away 7 ones from 3 ones. Let's change one of our 10 blocks for 10 1 blocks. Move them into the ones column. We now have 3 tens and 13 ones. Now we have enough ones to subtract 7. 1, 2, 3, 4, 5, 6, 7. How many 1 blocks are left? There are 6 ones remaining. Write 6 in the ones column. Now we subtract the tens. There are 2 tens remaining. Write 2 in the tens column. We're all done! So 43 subtract 17 equals 26. In the next video, we'll use bar models to help us subtract. Don't forget.
So as you can see, that's just a way for students to visualize a subtraction using the base 10 blocks. You will use that a lot in the classroom. So let's talk about some different concepts that we can use to teach young elementary students subtraction. The first concept is called the takeaway concept. An example is, suppose you have 8 basketballs and you give 3 basketballs away. How many do you have left? So this would be a situation where you would have a picture of 8 basketballs. You will actually show them giving 3 basketballs away, and then the student can count how many basketballs they have left. That is the takeaway concept. The comparison concept is like example 2. Suppose you have 8 basketballs and someone else has 4 basketballs. How many more basketballs do you have than they have? So students again can visualize the difference and they can count the difference between the 2 sets of basketballs. The last concept that we want to talk about in subtraction is the missing add-ins concept. Example 3 says, suppose you have 5 basketballs and you need to take 8 basketballs to the tournament. How many more basketballs do you need? And you can see that I've put the 3 squares here so that students could see that they needed 3 more, so then that they could count up to 8. That is called the missing add-ins concept. Just like with addition, with subtraction, we often start with the number line model. In our textbook, Zed wants to subtract 2 numbers. So using the number line, we're going to subtract 11 minus 3 equals 8. And we can show students that you're going to move over to the 11th spot on the number line, and if you want to go subtract 3, you're going to move back to the left 3 spaces and you land up on the 8. So where he lands is going to be the difference of those 2 numbers. Let's check out this video from our free textbook.
To subscribe.
And as you can see, here is Zed walking to his 11 spaces. We're going to subtract 3, so he's going to walk back 3 spaces. And where he lands would be the difference of 11 minus 3, which is 8. Again, this is the different ways that we could visualize this for students, which is really important at such a young age. Let's talk about the different algorithms that you're going to be teaching your elementary students. There are 4 specific algorithms that we want to cover in this lesson today. We're going to talk about the left to right algorithm for subtraction, partial differences, the add-up method, and of course our traditional subtraction algorithm in which we borrow in order to subtract. Again, it's important to introduce different algorithms for subtraction because you do have students who learn differently. You might have one student who really prefers partial differences and another one who does the add-up method. We want to be able to present material in different ways so that they can succeed, no matter which algorithm is used. Let's first talk about this left to right subtraction. Left to right subtraction, the definition states, it refers to the decomposition of the second number to make it end in 0. Then calculations are done mentally. So you want to rewrite this second number so that it ends in zeros. So let's take a look at that, an example like this. So we're going to rewrite that 58 as 50. So instead of 325 minus 58, we have 325 minus 50. If you can subtract those, we get 275. And then we're going to have to compensate for the 8 that we still have left in that 50. So we're going to subtract 8 more. When I take 275 and I subtract 8 more, I get 267. So 325 minus 58 is going to give me 267. Not sure why my numbers are not lined up for the second example, but we can get by with it. Again, we're going to take this second number and we're going to make it end in 0. So we're going to make 27 become 20. It's easy to take 86 and subtract 20. We get 66. And then we're going to go back and compensate for the 7 more that I need to subtract. So 66 minus 7 is going to give me 59. This is left to right subtraction. You can find some easy worksheets on different websites that allow students to print left to right subtraction or to practice this left to right subtraction. Let's look at a different algorithm. Let's talk about the partial differences algorithm for subtraction. This is an algorithm that instead of working right to left, we're going to work left to right, one place value at a time. What I mean by that, if we take 325 and we subtract 58 from it, we're going to start with our hundredths place. So I have a 3 in my hundredths place, so I'm going to take 300 and I have 0 in my hundredths place in my second number. So 300 minus 0 is 300. Then I'm going to subtract my tens. 20 minus 50 gives me negative 30. So 300 minus 30 is 270. And then we're going to subtract our ones. 5 minus 8 is going to give me negative 3. So 270 minus 3 gives me an answer of 267. Let's try another example using that same algorithm. All right, so this time, again, we're going to start with the hundredths place. This time, I have a 2 in the hundredths place. So 500 minus 200 gives me 300. Now we're going to subtract our tens. 40 minus 50 is negative 10. And then we're going to subtract our ones. 2 minus 8 is negative 6. And then I can just start left to right. 300 minus 10 gives me 290. And then 290 minus 6 gives me the answer of 284. That is partial differences. The next algorithm is called the add-up method for subtraction. You probably have used this algorithm on a weekly basis and never even realized that you were doing it. One way to subtract is to use the add-up method. It's like making change. If you've ever worked in a restaurant and you had to make change for somebody, they gave you a 20 and their meal cost $18.37, and you added up from $18.37 to get to 20 to see how much change there was. That is what we're talking about here. You start with a smaller number and you add up to a larger number in small increments, and then you add up those small increments. Let's look at an example of the add up method. All right, so to start more room, we're going to go to a new screen, and we're going to take 325 and we're going to subtract 58, this time using the add-up method. So what I'm going to do is I'm going to take the smallest number, 58, and I'm going to try to add it up. So I'm going to add 2 to get to 60. Now I'm at 60, so I chose to add 40 because it's real easy to get to 100. Now remember, I'm trying to count up to 325. That's my goal. So I'm at 100, I added 200 more to make it 300, and then to get to my starting point of 325, I added 325 back. Now I'm going to add all those that I added up to the increments. So 2 plus 40 plus 200 plus 25, I get 267. So 325 minus 58 is 267. Here's another example. I want to take that same problem that we worked in the previous algorithm. We're going to subtract it using the add-up method. So 258, I started off by adding 2 to get me to 260. I added 40 more to get to 300. Remember, my goal is to get back to 542. I added 200 to get to 500, and I needed 42 more to get to 542. And as you can see, I added everything that I added in increments together to get a sum of 284. So the answer to 542 minus 258 is 284. Of course, we do have our traditional borrowing method that you will teach students. In the traditional borrowing method, you trade up or use the borrowing concept. This is where we traditionally work right to left. The first example that we're going to do First example we're going to look at is one in which there is no borrowing. 9 minus 8, we're going to start from the right, gives me 1. 7 minus 5 is 2. And 3 minus 0 is 3. Then students are going to have to learn how to subtract by borrowing. So if we look at the next larger example, I cannot subtract 8 from 2. So this is where I had to borrow from the 3, and it becomes a 2. And the 2 becomes 12. We're going to add 10 to it. We borrowed 10. So now I can subtract. 12 minus 8 gives me 4. I'm left with a 2 in the tens place, but I can't subtract 6 from 2. So I have to move over to my hundreds place. I have a 1 there. So I'm going to borrow 10 from there. That's going to leave that as 0. And then I'm going to add 10 to my 2 that was in the tens place, which becomes 12. So 12 minus 6 is 6. When I go to the hundreds place, I again cannot subtract 5 from 0. So I'm going to have to borrow from the 7 in the thousands place. It becomes 6. So I'm going to add 10 to the hundreds place. 0 plus 10 is 10. And now I can subtract 5 from 10. And I get 5. And then I finish up. 6 minus 4 is 2. Of course, this is probably the method that you were taught for subtraction. It is a good method. There is actually a good screen or a good clip art that I found that I thought would be useful. It says, first, look at the ones. Ask yourself if there's more on the floor. If yes, then go to step 2. Go next door and get 10 more. Take 1 10 away. Add the 10 to the ones place. Next, subtract your ones, then subtract your tens. And so this is just a visual that you could give your students when you're teaching subtraction. Also, you're going to see that repetition and rhyme that you keep talking about and saying over and over again is a new way that we could get students to really lock that in their memory and become something that they use on a daily basis. There is sort of a new approach to our traditional borrowing method. It's where you subtract a consistent number from the subtrahend and minuend. These are the terms that we used in subtraction. I'm getting fancy on you right now, but this is something that you will be teaching in your elementary class. You can see, and it's not lining up on the PowerPoint correctly, but if you moved it up, we're going to take 4,001, and I'm subtracting 2 from that, and I get 3,999. When I take the 2,873, I'm going to subtract a consistent number of 2, and I get 2,871. This just allows me to be able to subtract without any borrowing of such. All right, so let's look at one more example. 3102, all we're doing is subtracting 3. Now, the reason that I'm choosing 3 is because it's going to make my number large enough in my tens and my ones place so that I don't have to borrow. So now instead of having a 2 in my tens place, you can see I have a 9. And so then I can say 9 minus 4 is 5, 9 minus 6 is 3, and you do end up borrowing on the last part, but your answer is 1635. So you can see how I can use this traditional borrowing concept that we all grew up learning, adjust it just a little bit, and makes it just an easier way to subtract. So some students might like that as well. If you want to know where we got our pictures and our resources, I've included the references for you.